graph a geometric sequence. What do you think?
Wait, are you going to get a parabola?
Well, that's a really good guess.
We're going to line.
Think it'll be linear? Okay, so let's look at this one. I'm going from 1 to 2, 2 to 4. So the common ratio here is 2 divided by 1, which is 2. So it's doubling every time.
Wait, okay, so you just divide. So, like, if you do 4 divided by 2,
Common ratio. 4 divided by 8 divided by 4, 16 divided by 8,
That's
it's
it?
2. So, yeah, the common ratio is 2. So it's going up by 2 every time. But it's not adding 2, it's multiplying by 2. What do you think?
well, I think that's.
I think this one
Thinks
is going
we
to be deeper.
I think it's just gonna be
Okay, so this order pair is going to look like 1, 1, 1.
1, 1.
And then 1, 2, 2, 2, excuse me. And then 3, 4. And then the fourth term is 8. And the fifth term is 16. So you think as things double, and they double every time, that it's still going to be linear, or it's going to be parabolic? Parabolic? So parabolic means that it goes down and comes back up.
Hold on.
Why did you do this, Kaylee?
Because there aren't any negatives in there.
Yeah, it's not going down at all, right? It's only going up. So it's going to be the going up part, but not the going down part. What does that look like?
Still.
That's a line?
Oh, crap. Oh.
What do we call this?
Okay, hold on. I know what it is. Oh.
Just studied it.
Oh,
There is an
I would-
asymptote. It's right here.
So it is an asymptote?
There is an asymptote.
That's what I was saying.
This is not rational. Remember, rational looks like this. It's not rational. Come on, guys. What do we call that?
Well, Dick Perry says it's a parabola.
You have it. It's not a parabola because it didn't go down. Okay. You have a cell. One cell. One cell. It splits in 2. Now you have 2. They split in 2, so now you have 4. They split in 2, now you have 8. Then you have 16, 32. What is it doing?
Exponential.
Well, it's
Thank you. It's exponential, and it's exponential growth. Good job.
good.
Okay? It's exponential.
Would never remember that.
So, an arithmetic sequence is linear. A geometric sequence is exponential.
Exponential.
So we're going to have to remember what we learned about exponentials in order to do these problems.
Pretty simple.
Yeah, that's not bad. I'm sending you
I think
PowerPoint.
the arithmetic
So it's on there.
sequences are-
Okay, so just like we had formulas when we did arithmetic sequences and series, we have formulas for doing geometric sequences and series. So this is the formula for finding the nth term of a geometric sequence. That's the formula for finding the nth term of a geometric sequence. So on this problem, it says find the 8th term of the geometric sequence for which the first term is -3 and the common ratio is -2. So I'm going to write down all the things, all the variables in this problem. Find the 8th term. So what does that information tell you?
Well,
Eight
n equals
is
8.
N must be 8.
Yeah.
So I'm looking for the 8th term.
Here.
What else do I know?
Negative 3 is
The first
R is
term.
-2. That's your common ratio. And what?
A1 is negative 3.
Good. The first term is -3.
Here.
Now, I know what goes where, so I just stick it into the formula. A sub 8, because I'm looking for that 8th term,
Right.
equals the first term, which is a -3, times R, which is -2, to the 8 minus 1 power. N minus 1 and N is 8.
Am I supposed to recognize? Oh, are we supposed to recognize? Know this.
You don't have to memorize this formula,
Yeah.
but I do want you to know what all the pieces and parts mean.
That's That's 60.
Okay, so then we just work this out. The 8th term is equal to -3 times, I should have put that in parentheses, -2 to the 7th power. So -3 times -2 to the 7th power. Oops, did that wrong.
Why don't you just do negative?
Why don't you just do 6
Is 384.
Would you get the same answer if you put like 6 and 7 power again?
No. Order of operations says you have to do exponents before you multiply. Good question.
Alright, good job, Mr.
Thanks.
Okay. So now